Okay, so I got this new app on my Android tablet, and I have been going crazy doing these videos, and my family thinks I'm crazy. But hopefully these are of some benefit to you guys, and I'm not just doing this for myself. But anyway, so today I'm going back over 45, 45, 90 triangles, and then I'll do another one on 30, 60, 90. Because the quiz that I gave, not to the regular geometry, they did okay, but my pre-AP students really struggled on that quiz, and I did make it a little bit more challenging. And I've always said the quizzes are harder than the tests, but in this case, I think the test is going to be about the same as that quiz. Now, if you're one of the students that got an 8 or a 12 on that quiz, I would be very concerned when it comes time for that test. So we need to make sure that we understand it a little bit better. And I went ahead and drew out a triangle, and that's a 45-degree angle. And I didn't have to write the other 45-degree because, after all, we know they add up to 180. So the fact that these are both the same angle means that the two legs are actually the same. So these 45, 45, 90s are always going to be right isosceles triangles. And this ratio basically states that the two legs are the same, which makes sense because if the angles are congruent, then the sides opposite also have to be congruent. But the hypotenuse is always the square root of 2 times bigger than the leg. So for instance, if I tell you that 7 is the side length for this first side over here, then I know that the other leg has to be 7 because it's isosceles, and I know that the hypotenuse has to be 7 times the square root of 2. All right, so let's do another example. All right, this time, okay, so this is a 45, 45 again. And this time I'm going to give you 10 square root 2 as your hypotenuse. So, you know, you have that formula chart, and it has those triangles on there with these ratios written in. So it's not like it's something you have to memorize. Just remember that when you're trying to figure out what the side is, you're really writing this equation, x square root 2 equals 10 square root 2. And the square root of 2's cancel out, because if they're on both sides of the equation, you can just cancel them out, and you're left with x equals 10. So if that's the case, that means this side here is 10, and so is this x as well. Because if the square root of 2's are the same, then the number in front of that square root 2 is going to be your x. Now, what if I give you a different number? What if I'm going to clear this again. What if I give you the square root of 12 over here? Oops, it would help if I wasn't on eraser. So here I've got square root of 12, and this again is 45, 45. All of them are going to be that because we are, that's what this whole discussion is about, is 45, 45, 90. So remember I said x square root 2, that this is going to be x, this is x, and this is x square root 2. Well, square root of 12 is different from the square root of 2. So you have two ways of going about doing this. You could start by simplifying the square root of 12 and go from there. Or you could just go ahead and set up that equation, x square root 2 equals the square root of 12, and solve. And remember, the square root of 2 is still a number, so you're going to divide by it like you would if it was 2x. And this cancels out here. And remember, you can divide numbers that are under the radical. So 12 divided by, if the square root of 12 divided by the square root of 2 is going to be the square root of 6. So remember, this has to be, the hypotenuse has to be square root of 2 times bigger than the legs. So if my hypotenuse is the square root of 12, then that means these sides here, the legs, have to be the square root of 6. Because for me to get the hypotenuse of square root of 12, I have to be able to multiply the square root of 6 times the square root of 2 to get that. So there's one that's an example where your radical, on the hypotenuse doesn't necessarily line up with that whole x square root 2 format. Remember that it's not a specific format that you're going to have whole numbers on the legs and a radical with the square root 2 for the hypotenuse, it is a relationship. So whatever my leg starts out being, my hypotenuse will always be square root 2 times bigger. Okay, so I'm going to clear this one, and I'm going to do a couple more examples. What if I give you, square root of 3 for this leg, and this is a 45, 45, 90. That's supposed to be a 4. If this is a 45, 45, 90, and I tell you that this is square root of 3, then this is going to be square root of 3. And this is going to be square root of 3 times the square root of 2, which results in the square root of 6. So you really have to understand simplifying radicals to be able to do well in this part, because I'm going to expect you to simplify. For instance, let's give you another one. This time, I'm going to put the square root of, let's see here, the square root of 4. Okay, well, honestly, you should be able to simplify this already, because this is going to be 2, right? And if that's 2, then this is 2, and this has to be 2 square root 2. But let's just say I didn't realize the square root of 4 was 2, and I left this as square root of 4. Well, this is the square root of 4 times the square root of 2, which is the square root of 8, and at that point, I would expect you to simplify this. So square root of 8 is the square root of 4 times 2, and that's 2 times 2, and bring that other 2 down. So I circle those. So for every 2 under the radical, it's equal to 1 on the outside. So you can see that works there. And then this 2 is sad. He doesn't have a friend. He's stuck behind, and there's that 2. It goes there. So you can see that if you didn't simplify it ahead of time and said the square root of 4 is 2, once you got over to that hypotenuse, you would have to simplify it, and you would still get the same answer. I'm trying to think if there's any other ones that we could do. Okay, how about I give you an expression for one of the sides? So this time, I'm going to give you the expression 3 plus the square root of 2. And again, if that's the case, if this side is 3 plus square root of 2, then the other leg also has to be 3 plus the square root of 2. And then if I want to figure out what the hypotenuse is, you're going to write that expression, 3 plus the square root of 2, and put it in parentheses, and that's times the square root of 2. So the square root of 2 times 3 plus square root of 2, and we have to distribute that across. So square root of 2 times 3 would get me 3 square root 2. And then when I multiply the square root of 2 times the square root of 2, if you saw that simplifying radicals part 2, I talked about a number, a radical multiplied by itself. The radical goes away, and you're just left with the number underneath. Because the square root of 2 times the square root of 2 is the square root of 4, and that simplifies down to 2. So the answer for the hypotenuse is 3 square root 2 plus 2. Okay, hopefully that helps, and I can't really think of anything else that might be confusing on that. Oh, actually I do. I do think of one that, actually this is one of the ones that gives everybody the headache. Can't believe I almost forgot it. So, what if I give you a whole number for your hypotenuse? When you're expected, if this is x, and this is x square root 2, what about a whole number? So the example that we did where we had the square root of 12 as the hypotenuse wasn't too bad, because I could divide by the square root of 2, and that meant I didn't have a radical in the denominator. But we really don't like having radicals in the denominator. It's really frowned upon. So when I write this equation, x square root 2 equals 12, and then just like I've done on the other ones, I divide by the square root of 2, I cannot divide a whole number by a radical. So it's left down in the bottom in that denominator, and you've got to do what's called rationalizing the denominator. And to rationalize, you simply multiply by the radical that's in that denominator over itself. So I'm going to multiply this 12 divided by the square root of 2 times the square root of 2 over the square root of 2. And what happens is when I multiply that out, I get 12 square root 2 over the square root of 4. And the square root of 4 is 2. So I get 12 square root 2 over 2. And then these two can be simplified. So you end up getting 6 square root 2. And that 6 square root 2 is x. So that means this right here, this leg has to be 6 square root 2. That's not a b, that's supposed to be a 6. And this is also 6 square root 2. The pattern is to divide by 2 and then stick a square root 2 on the end. But I think from watching people struggle on that quiz, it's just easier to recognize how to rationalize the denominator by multiplying by that radical over itself. So that it has been a source of struggle for some students, but hopefully this has kind of helped a little bit. Okay, that is all I've got for today, and just kidding, I'm going to do a 30, 60, 90 on another video, but hopefully this helps you understand what a 45, 45, 90 triangle is and how to simplify those radicals as an application of that. All right, thanks.